Okay, good morning. Thank you for coming. I am Luca Relandini from Cisco. I am a solution architect, and I work on the product lines for data center automation and cloud. You are lucky to be here today because I will tell you a secret. Cisco has become a software vendor. Actually, probably you know that we are an infrastructure company. We sell networking products and servers, probably best servers in the market. But today, I'm talking about a software project, which is an open source project. So not something Cisco is making money out of, but something that has been given to the community. And it is extending the policy model that we are in other product lines to the world of containers and microservices. So before we start, just to understand who I'm talking to, I would like to know how many of you worked with containers already? Everybody? Microservices? Have you implemented application? Okay. And are you networking experts? That is nice to see, because I'm not a networking expert myself, so I will not be embarrassed by your questions. So, today, we are talking about microservices and the way they scale in a production environment. Of course, that is a challenge, because in a development environment, it's pretty easy to configure whatever you need. But if you move to an environment where you have thousands or hundreds of thousands of microservice instances, of course, managing them could be difficult. So you already know that the container is a very smart deployment unit that brings everything is required to run your code. So wherever you deploy that, it is assumed to work. It's smart, it's efficient, it does not bring the operating system with it, because every container shares the kernel of the box. This is something you already know. So microservices are groups of containers. Actually, they are the logical units when you design the application. So you can break down the complexity in microservices, and they will be deployed as containers in the best case. So we are addressing those use cases. So with the advent of microservices, the way operations work has changed, of course, or should change, because sometimes they're still catching up, and there are problems in moving applications to production. Of course, now there is more collaboration between developers or software designers and the IT administrators and the operations team. They are assumed to work together. Generally, there are small teams that own a microservice or a group of microservices from end to end. So from the collection of requirements to the design, implementation, testing, and production. So whatever happens to that microservice, they are responsible for that. And there is the feedback loop that makes it more efficient and agile. That means that deployment in productions are more frequent. You can change the application during a day, even more than once a day. The giant on the web demonstrated they do new deployment in production every few minutes, sometimes. And of course, the architecture of the application is more modular. So you can do partial upgrades, partial updates of your code in production without no problem. And you can scale every component independently. So the big numbers that resource managers like Kubernetes or other systems do in production, of course, will have demanding requests on the infrastructure. So the life cycle is agile. They collaborate much better than in the past, but of course there are still different people with different roles in the play that have their own needs and their own preference. And of course there are legacy processes or a culture that requires for safety, performance, everything. And this is slowing down the adoption, because there is a big hype around containers and microservices. Many people learn how to build them, but of course, moving mission-critical applications to microservices is not as fast as someone would expect. And one of the reasons for being safe or prudent from a CIO standpoint or from the IT administration standpoint is the complexity of networking. Because if you have so many endpoints on the network, the attack surface, of course, increases. The performance and stability of the network must be cared of. And so they are learning, and they are trying to find a good solution for that. So from where we only had servers attached to a physical network, the world has changed. So complexity increased because moving to virtual machines, you have 2 layers of networking, the physical network and the virtual overlay. So if you don't have the right tools or the right architecture, it's already complex when you have 2 networks to manage together. But with containers, you have 3 layers, because generally containers run within the virtual machines. So there is the networking bridge in the guest operating system that needs to interact with the overlay network of the virtual machine that will interact with the physical network in the infrastructure. So there are many moving pieces, and you should be able to work with them smoothly. So sometimes you have physical load balancers or firewalls, or they could be virtual instances of virtual machines doing that job. It's not always easy to insert those networking services in the data path of your microservices. Sometimes performances are affected because there are many switches, many configuration points and tuning that you should do to be performant. And sometimes you lose the advantages given you by a specific hardware infrastructure that could be very performant, but if not used completely, it cannot bring the value you have paid for. So let's have a very short look at the networking in containers. Only 3 slides, because as I said, I'm not a networking expert, and I don't want to get you bored with something that is probably not relevant to your job. So in the host where your containers are running, there are some mechanisms that should provide essential features. First of all, IP connectivity. Sometimes you can give an IP to every container. Sometimes you do some mapping of ports and IP addresses with the interface of the host. But of course, that is the primary feature that you expect from a networking implementation. And then IP address management. So you should have address pools and subnet pools that are assigned to microservices as long as you deploy them. And of course, the traffic should be routed externally to the infrastructure and possibly to internet to make the application work. So there are standards that have been created to implement the networking part of the runtime as a plugin. So everybody can create a plugin based on the specification given by Docker, in this case, and other players in next slide. So the container network model is pretty simple because the network namespace of the container is within a sandbox that have specific functionalities. And the plugin for networking that you provide, Contiv is an example of this kind of plugin, will do a very simple job. So every connection of a container to a network means the creation of a couple of virtual Ethernet interface, one within the sandbox of the container, one in the bridged network of the host. A network is just a collection of endpoints that are connected to the same network, so they can talk to each other, regardless of the mechanism that allow the traffic to flow. So there are some API that must be implemented. Everybody could create a plugin for Docker or Swarm, and of course, all the related tools that manage Docker. Another alternative implementation is CNI, the Container Network Interface. This has been created by CoreOS and is now adopted by Kubernetes, that probably is the most used resource manager for containers and microservices. And it is even simpler, but gives the plugin full control of the configuration of the network. So it's not the runtime that creates the endpoints and the network, but the runtime tells the plugin, please attach this new container, and I give you all the information to the network. So the plugin will enter the namespace, the networking namespace of the container and creates its own stuff there. So there are few differences who is active or passive in this workflow, and the number of API and parameters that are passed. So there are essentially two architectures where they allow a third party to create a plugin for the networking. And there are very good implementation in the open source world. So you know probably Calico, Flannel, and other implementation of overlay or plugins for that. And Contiv is adding to this list. Probably at this time, Contiv is the most advanced, more performance, and most versatile solution for containers networking. And we will see how we implement both this architecture. So we can plug into Docker, we can plug into CoreOS and Kubernetes, and of course, all the tools that are wrapping those, like OpenShift and the others. So whatever solution you use, Contiv is one possible solution for your networking. And we will see what it is providing in addition. So we said that there are specific roles in the project lifecycle that have specific requests. So developers or designer just care for the application they're building, their project. They do not care about the infrastructure and other applications running at that time. So they want to be fast, they want to be agile, they want to have a solution that is as much as integrated with their development tools as possible. While, of course, the IT administrator that must ensure that in the data center or in the public cloud that is administering and offering services to others, everything works very well. It is stable, it is performant, it is reporting correctly, there are no security issues, so something that is more related to the infrastructure rather than the application code. But of course, they both need to be satisfied by the solution that is selected. So managing the container networking on a policy base makes them happy. Policies are something that makes your work simpler and more efficient because you have declarative tags that make the discussion and the exchange of information easier. They can be prepared by the admin and consumed by the developer just to indicate what they expect from the infrastructure. So they don't need to understand the complexity of the technology. When I worked in the software industry before joining Cisco, I was an enterprise architect. I designed application. And when it was time to go to production, I spoke to the system engineers, but we spoke different languages. So I told them, I need to set up a cluster of 64 nodes of WebLogic, and they need to talk to each other. I don't care if they all run on the same machine or on 8 different machines. They need to talk. And they said, yes, talk. What does it mean? Which protocol, which subnet, which VLAN? I didn't care. I didn't even know. So we are in a similar situation here. I just care the application and the way my components relate to each other. I don't want to know the technical information about the network. So declarative tags makes this much simpler. And of course, since we are talking about hundreds of components or thousands of components, configuring them individually is practically impossible. So we use Kubernetes or Docker Swarm to manage big groups of containers that we aggregate in microservices. So making that possible also in the networking part, of course, improves the quality and the stability and the performances. So Contiv is an open source solution that you can download and use immediately. There is no price. It's offered to the community by Cisco, and people external to Cisco are contributing to that. So it's on GitHub. You can also contribute yourself if you like. And is meant to match two different intent. So the information and the objectives of the software developers with the information and the objectives of the IT administrators and the operations team. It can work on any platform, so on physical servers, on virtual machines, in the cloud, wherever you deploy your applications. So here we are representing in a fake format the right side. It's not the real format you configure Contiv, but it's just to show what kind of different information you are managing here and what kind of intent. So on the left side, you have something similar to Docker Compose, an example, explaining how the microservice is built from different components. On the right side, you see the operational intent. That means how it should work in the production development or testing or production environment with some constraints on security, on bandwidth that is allocated to make a reserved highway for that application without disturbing other applications. And of course, every route that you want to allow and those that you want to close for security reasons. So matching those informations and intent together makes the management easier. So Contiv is made of different parts. We have user interface that could be the command line interface or REST API that can be integrated by your application or the management system you have. And you have a graphical user interface that generally is used by the administrator. Then you have the plugin for Contiv for all the resource managers you may desire to use. And you have the runtime, which is actually running on every host, physical or virtual or in a cloud, where you are running and deploying your application. Of course, if you have specific hardware that brings you an advantage in terms of manageability of performances, we will see some example later, you take full benefit from the feature of this hardware. So essentially, Contiv is a networking solution that works on any infrastructure, any platform, and provides you different kind of networking, layer 2, layer 3, overlay, physical networking. So we offer advantages to the developers because the policy that I mentioned before make their work easier, and to the administrator because it is enterprise grade, it is robust enough to be managed with their expectations. So integrates into the products or projects you see there and can be consistent with the operational model and the governance model that they have in the enterprise or at service providers. And it integrates well with the underlying infrastructure. I don't know if you have been exposed to Cisco ACI, that means application-centric interface. It is a product line from Cisco. There are switches that are managed all together as a single system. So you are no longer going to configure a single networking device with individual configuration, but you have a software controller that manages them all. So it's much easier to manage big networks. And this is our solution for SDN, solution-defined networking, because you define the behavior of the networking fabric through a software interface. You can model that based on a policy model that is the same that you will see for Contiv. So we are matching the same way we manage the physical infrastructure with the virtual networking for virtual machines and for containers. Everything is consistent, and this is an advantage if your application have components deployed in different architecture, because you could have the front end or the business logic made by containers or virtual machines, but maybe your database server is a very big hardware machine like Oracle Exadata, as an example, that is not a container. So you have to connect to it in the physical world. So in complex architecture, having a consistent model to manage different networking is a value. If you don't have ACI, we still work integrating the physical infrastructure from Cisco, from other vendors. So the virtual implementation of the networking, which is Contiv, can delegate specific functions to the hardware to make it more performant and efficient. So Contiv is an open source project that started more than 1 year ago. It has been released officially in February this year with version 1.0. As I said, is available on GitHub. You can use it. Soon, a commercial distribution will be offered as an option. So you will still work with the open source version, but if you are an enterprise and you want to have a dedicated support instead of relying on the community like you do with Linux, but you want a vendor to ensure that everything works, you can buy the support service from Cisco, like you do with Red Hat, with Linux, or OpenStack, or other open source software distribution. So the software itself is for free. If you want some certified support, you will eventually pay for that. But that's not required, actually. So we are addressing some specific, wide requirements, which are availability, performance, ease of management, security, and so on. And of course, openness to every platform to run. As I said, we offer tools to create the configuration, to operate that, to monitor, to collect metrics, to create your own dashboard. And of course, we have a distributed and stateless implementation that ensures availability and performances. So if a node of your runtime crashes, you can just restart the server because the networking runtime will take the information from the master and restart working immediately. So it helps scaling and having a reliable infrastructure. And of course, we integrate with all the best, no, actually with all the solutions on the market or on the open source panorama for managing the microservices. This is the architecture of the product. So you can see the blue box on the upper left corner is the client. So it could be an external client or the command line interface that we offer that actually is a program that acts as a client to our master. So master is a piece of software that can be multi-instantiated. So you see 3 rectangles overlapping in the picture because, of course, must be highly available. And then you have an agent running on every computing node. So in every host where you run Docker or other container solutions. So they contain the policy engine and the database and a distributed key-value store that is used to match all the nodes together. And of course, the plugin in the runtime that talks to the Docker runtime or to the scheduler, so the resource manager runtime. Is there any questions so far? You can interrupt me at any time if there is something that is not clear enough or requires a deeper investigation. So now it's time for a demo. That is probably the most interesting part because that is the introduction. Everybody does it. So I guess you are waiting for that. So the demo I am presenting to you is available on GitHub. It's a Vagrant environment that you can easily download and run on your computer, in your laptop, in your lab. It's very easy. And there is a step-by-step guide to go through it. So I invite you to go there and do it yourself on your lab. I'm not running that live now because time is short, and to avoid every uncertainty in typing and any demo effect, I executed the demo in my environment last week. I took a lot of screenshots and I pasted them here along with information and comments. So I've already delivered this presentation. I've seen that it works. It's probably less appealing than a live demo with all the risks, but probably you will get a better value from that. So let's have a look initially on how Docker sees the network. In Docker itself, without using Contiv, you can create different kind of networking. So if you do a network ls, you will see all the networks that have been created in your environment. So if you create a new container, it will be attached to the network that has been configured as the default. You have to do nothing. Or eventually, you can specify the one of the networks that you have created to attach it to it. So if you go and inspect the bridge, the virtual bridge in the host I hope you can read it. It's small, but I highlighted the most important part. So a network is called, is based on the default driver that is using OpenVSwitch in Linux. Has created the network. You see the subnet and the gateway here. And the container that we have just created is attached to that network and has got an IP address from the pool. If you enter the container and you run the command ifconfig, you see that that is exactly what you see on the OpenVSwitch side, on the networking side. So now let's put Contiv in the play. netctl is the command line client that actually I presented before is a REST client of our master. So it will talk to the master node in Contiv, one of the master nodes, and send the commands to create configuration and to operate on them. So with netctl, you can issue commands like net create, net delete, group create, policy create, and so on. It's pretty easy. You will see examples in the next slides. So here I am creating a new network called ContivNet, last parameter in the line, based on a specific subnet. So if I issue the netls, so give me the list of the networks through Contiv, I will see that. So in the default tenant, a network has been created, ContivNet. It's based on this encapsulation. You can use VLAN, VXLAN, overlay, and different kind of networking. And that is the subnet that we are using. Now, from a Docker standpoint, if you issue a new network ls, you will see also the new network that has been created by Contiv. That means they are integrated and they are talking to each other, of course. So I can use ContivNet now to deploy any new container, any new microservice in my traditional way. So possibly the IT admin has created the new network, or I create it myself. But from that point, that is a normal Docker network that I would use like every network I created directly in Docker. So from a Docker standpoint, if I inspect the network, I will see similar structure, similar information. The only thing that changes is the driver. So it's not the default driver for OBS, but it is net plugin, which is Contiv. So one container that has been deployed by default is the DNS, and it has got an IP address on the network that we created. So now we will attach a new container to the Contiv network. So I'm using the parameter --net equal the name of the network. So if that is a standard Docker network or a Contiv network, nothing changes. It's managed the same way. Then I will create another one, giving it the name Contiv C5. That means container 5. Actually, I created 5, but I just copied last line. So this is the list of containers where you see that some of them were created previously to ContivNet, so they are attached to the traditional network in the Docker environment. So if you go inside one of the containers attached to Contiv, you can ping the other containers in the same network, but you cannot ping the old container that was attached to the default network. So, of course, each network is isolated as you would expect. On top of that, we can manage tenants. So tenants are groups of users, but they are also environments that are isolated from each other. So they are completely isolated namespace. They have their own resources. Generally, you create one tenant per project. So all the resources for that project can eventually overlap with the same name, same subnets you use, same IP pools with other tenants without creating any interference and any side effect. So within a tenant, you are in an isolated world. You can do whatever you need without disturbing the others and being disturbed by them. So with tenant, with another command in netctl, you can create new tenants. So tenant create, name of the tenant. And if you issue the ls list command, you will see that in addition to the default tenant that existed already, I have created the blue tenant. Now, I will create another network in the tenant. I'm using, on purpose, the same name, ContivNet, that I used before. So the first one was created in the default tenant. So this is the old network. So with the net control net list, I'm not seeing the new network that has been created in the tenant named blue. If I repeat the same command, net control net list tenant blue, I will see tenant blue, same network. So the name is the same. The subnet they are using is the same, but they are not talking to each other. They are completely isolated because they belong to different tenants. So every tenant can simply ignore what other tenants are doing. They are not stepping on each other's feet. So to use the new network in the blue tenant, I have to specify the tenant when I associate that to the new container. So here I'm running a new container and giving it the blue network. Is that clear? Okay. One step ahead is using policies. So far, I've been doing something very traditional, eventually partitioning my environment by tenants. Now, I'm keeping the promise of using policies and making your work simpler. So a policy is a container for some rules. I create that object once, and I can reuse that in many places. So different microservices can reuse the same policies, or different environments. If I create a development environment, I will have some policies for that environment. When I move my application to the integration test, I will have different policies that are bound to the environment and are inherited by all the containers and microservices I deployed there, and similar for production. So when I create a new policy, it is empty. Net control policy create, name of the policy. I can list the existing policies, and then I will add rules. So to a policy, I can add one or more rules that will manage the security aspect of the networking and the performance aspect. So I can limit the bandwidth, or I can reserve bandwidth for a specific service. I can make it available just from one network and prohibited from other networks, and so on. So you add as many rules to the policy as you need. You can give them a precedence, so which is evaluated and enforced before, and which is later. And then, once you have a policy, of course, you can apply that to a specific single container or to a microservice. But what creates the bigger benefit is using groups. So if I have a group with 10,000 container instances in it, and I apply the policy to the group, every container will get the same enforcement of the same rules. So it happens when you do auto-scaling. So when Kubernetes or Docker Swarm add more instances because some thresholds has been passed and you want more computing power. So when you create a group, you associate one or more policy to the group. So this is the syntax. It's easy again. So we are just showing command line examples, but the same commands are also available through the REST interface and, of course, in the integration plugins with the resource managers that we managed before. So now a DB group has been created and is consuming the policy that we created in the previous slide with some filtering of the traffic. And now I can create new containers and add them to the group just using the group name instead of the network name. So syntax in Docker to create the containers is the same, but instead of using a network name, I'm using a group name. And the group brings all the policies that have been associated to that. So if you go and see what is the IP address of the Contiv database, you see the IP that you expected. So now we create 2 more containers, Contiv DB2, Contiv DB3, attaching them to the same group. So DB group is the common container for all my containers. And that could be matching a microservice. So as an example, an application service that consumes the database and offers some business-related service. So as I said, autoscaling will create many more instances within the group, and they will immediately get the same configuration in an instant. So it's fast as you would expect in a very performant environment. And it is easy because you don't have to manage every endpoint independently and repeat the same operation. So it matches the way application designers see the world, because they see a front end, maybe an application tier, a database tier, could be much more complex than that. Of course, this is a very traditional 3-tier application. But you can create groups and define the relationships across groups. So as an example, the service in here delivered by all those containers can only be accessed by those respecting the rules I've defined here. This is called a contract in the Cisco ACI world. Contiv is mimicking that policy model, so you work exactly in the same way as you would do in the physical world or with the virtual machines. It's consistent. So you can group the application components, and you can follow their very fast and ephemeral life cycle without doing anything specific for every container. Of course, it works with very large clusters of nodes. So if you run your containers in virtual machines or in bare metal hosts or instances in the public cloud, they can be hundreds or thousands of servers running millions of containers. Everything will work because we tested that, and it is very consistent. So this is a summary of what Contiv is offering. Its cluster is multi-tenant. It brings you isolation across different networking, allows you to give priority to a specific traffic. You can monitor performances and every metric on the network. It is integrated with the tools to compose your application and define your microservices. Integrates very well with the physical hardware, taking advantage of the specific features and the performances you can get from that. Can sustain a very high throughput and is scalable to a wide cluster of nodes or many clusters. And this is the value proposition. So in my opinion, in Cisco's opinion, actually, this is the most efficient and easiest way of managing networking for your microservices. It is compatible with everything, so with every platform you run your containers on, and with the management tools that you prefer to use. So we don't mandate you to use a full Cisco stack or a specific product that we have a partnership with. It's open source, it's open interfaces, open code. You can do whatever you want. And recently, we worked with Docker. So Docker Data Center integrates Contiv out of the box. You can also find it in Docker Store and download it as well from GitHub directly. We certified that with OpenShift, because actually OpenShift encapsulates Kubernetes. We also have a developers community at Cisco. You should take note of that. I will show some links in the final slide, but if you go to developer.cisco.com, we have plenty of documentation, code examples, tutorials, sandbox to allow you to test without even installing it in your computer. So it's easy to use it and to learn it. If you go to the Contiv website, it's on GitHub, as I said, you will find the tutorials, the source code, the executables, and also the lab environment ready to download as a Vagrant setup. So it will run in virtual machines with VirtualBox in your computer, which is free. And it's easy. Just Vagrant up, and then you start executing the Contiv command in the environment that you have created. There are recorded demo, probably better than mine, because it's a video and they explain and they do all the commands. But I grant that if you download the tutorial from the web, it will be very, very easy for you to learn. Comments or questions?
Hi. Can you manage switches as well?
Manage what? Sorry?
Switches, traditional switches.
Yes, it integrates with the physical world. So if the switches are the Cisco ACI architecture, much better. But of course, if you have standalone switches from Cisco and other vendors, you have full integration for the BGP and other protocols.
So you can, in fact, define those gigabyte interfaces are in this VLAN and
yes,
this trunk. And
absolutely. So you will create a fabric across all the hosts and then use parts of that traffic, part of that bandwidth to delegate, to consume that for your microservices. Oh, okay.
Sorry.
Yes.
We have a microservices environment where we have about 20 microservices running in Mesos, and we use HA proxy in front of that to distribute the load also, because some of our microservices have multiple instances, so HA proxy knows.
Yes.
How would Contiv fit into, would it help us?
Actually, Contiv does even more because we have a load balancer built in. So right. Once you create a service, the service will have a virtual IP address that you can configure in HA proxy. So HA proxy will send it to the Contiv runtime that will distribute that all across the cluster to all the instances.
Because Contiv also integrates with Mesos, so it knows where everything is. Yeah.
So the east to west traffic across the instances is load balancing by Contiv itself. And the advantage is that when we create a virtual address for the service, it's advertised through the real DNS. So it's not a value store put in, key value couple put in etcd or other console.
So you're actually adding service discovery to Mesos, more or less.
Yes.
Yeah.
So is there any support for multi-tenant or multi-data center things? Like, normally you would set up a VPN then, or encryption, right? So is there anything?
So we integrate with LDAP or Active Directory to segregate the users. So if you have tenants created in your identity system, they will be immediately matched in Contiv. So every admin or developer will only work with the resources of that tenant. Then,
sorry, it's more about that the traffic would go over public internet, or is it over multiple data centers that you could make routes there?
Yes, of course. So the cluster can be very wide and can be across different data centers. So we will integrate into the external networking configuration to allow the usage of the VPN. So you can have half of your application in your private data center and half in Amazon. They will communicate seamlessly. Any other questions? Okay, so I will put back the links. You will probably see the...
And also, please remember to vote the session before leaving. Thank you.
If you are interested in the links, you can see them here. And my Twitter handle is Luca Relandini, all attached. So you can send, or my email address is luca.relandini@cisco.com. So every question you might have, I will try to answer. So thank you for coming here, and have a good experience with the tutorial.